Hello and welcome back. It's your boy back at it again. What do we got today? We got a modeling and problem solving problem. Find the rule that has been partly covered on this function machine. It is known that the function is of the form qa equals something a plus 5 or qa equals something a minus 5. And we've got some inputs a and some outputs qa. Oh, that's a lot to interpret. So the table tells us that a, when a is 2, q, a, got to be careful, make sure the q's look like q's, gives us 3. Wow. Okay, so we've got two options. We have the first rule to look at, and the first rule says that qa equals something times a plus 5. So if we just sub in what a is and what qa is, because we know that qa is just this, and a, well, that's just this. So the only thing that we do not know is this question mark. And instead of writing a question mark, we could write a letter. So we could write qa is equal to, let's say, ka plus 5. So we've got a lot of qa's to try and a lot of a's to try, and we can use that to find what k is. Now it could satisfy this first rule, or it could satisfy the second rule, which is q of a equals question mark a minus 5. And we can do the exact same thing here. We know that that question mark is something, so let's actually give it a letter, the letter k. And we'll figure out which one of these actually works with this table of values, because we can think of this input a and output qa as a table of values, just x's and y's. So let's begin with our first set of data, 2 and 3. So q of a equals 3, leaving k there, and a is a 2. Whenever you're substituting in, it's really nice to keep brackets there. Helps you keep track of any negatives. We can rearrange for k now and see if this works. So I want to take away my 5. So I'll have negative 2 equals k 2. Well, I could just write that as 2k really. So let's take it back a bit. 2k. I want to get the k by itself, so let's divide both sides by 2, and I will get negative 1 equals k. So that's using our first set of data, 2, 3. Now we've got a lot more. We've got 5, 15. Let's see if that works using our first rule of q of a equals ka plus 5. So let's sub that in. So q of a equals 15 equals, now we've worked out k, let's sub in that and see if this still works. So negative 1, and our a value this time is 5 plus 5. So let's rearrange this. So 15, oh wait, let's just expand the brackets. 15 equals negative 1 times 5 is negative 5 plus 5. 15 equals 0. That does not make sense. So that means that our first rule is out. This is gone. See you later. So let's investigate this second rule. So let's sub in our first set of data. Let's write it down this time. Sub in a equals 2 and q of a equals 3. Now let's see if this works. So 3 will equal k times 2 minus 5. Let's rearrange this, or expand some brackets and rearrange. So we want to get rid of this minus 5, so let's plus 5 to both sides. And we'll expand this bracket as well, so we'll have 2k. So now we just divide both sides by 2. We will get 4 equals k. That's pretty nice. Now, let's check. Let's sub in 5, 15. So sub in a equals 5, and q of a equals 15. Let's see if this works. So 15 equals, and we know k, so let's write it down, 4. And a is 5 minus 5. So 15 equals 4 times 5, that's 20. Minus 5, this is looking pretty good. 15 equals 15. Well, that's true. That statement, 15 equals 15, is true. So our rule is looking pretty good. But we've only checked if it satisfies 2 pieces of information. This 2, 3, and this 5, 15. We've still got one set of information. We've got 8 and 27. If we stopped here, and maybe this question's really tricky, that 8 and 27 might not work. So we have to test it. We've got to check it out. So I'll just do it. I'll squeeze it in over here. So A is going to be 8. Q of A is going to be 27. So let's sub those in. Now we'll have 27 equals 4 times 8. Because remember, A equals 8. That's this A here, which is this one here. Minus 5. Let's hope this works. 27 equals 4 times 8. What's that? 32 maybe? I'll just say it's 32. Minus 5. We will get 27 equals 27. This equation is true. 27 does equal 27. So I'm pretty happy to say. Ooh, how happy am I? Maybe I'm this happy. This is our equation. That is the rule that has been partly covered on the function machine. Alrighty, that's all the time we got today. Thanks for joining me, and I'll see you next time.